Greetings from Yogi Coder Studios. Today's topic is Python generators. In this class, we covered generator expressions and generator functions, what they are, how to use them, how do they compare to regular Python functions. We give plenty of examples and even a pointer to a great resource in the Python community for generators. Let's start by defining what Python generators are. Generators are a type of construct that delays results such that they are produced only when they're needed. There are actually two different types of Python generators, a generator function and a generator expression. Generator functions use the regular function def statement to define them, but they use a yield statement instead of a return statement. Generator expressions are closer in how they look to list comprehensions, but they return an object that produces results on demand. Since generators do not return results all at once, they save memory. This delayed results ability is implemented by the iteration protocol. Any function that uses a yield is defined in Python as a generator. Each generator is an iterator. Why is that? Since by definition, each Python iterator must be able to define two methods, the next method and the iter method, generators implement both of these as well. So we said in the last slide that one of the main differences between a regular Python function and a generator function is that the generator function makes use of a yield statement where the regular function makes use of a return statement. So let's look at the differences between these. The return statement, used by the generic function type, sends back a single result as soon as it's reached. And once it's reached, the function exits and sends control back to the object that called it. The yield statement is used with the generator function. It can produce a single value, suspend and return control back to the caller, then at some later time pick up exactly where it left off and yield back another value. Generators yield a sequence of values over a period of time. They are able to resume their execution and state. In other words, where they are in the code execution and the whole local scope and which values are assigned to the variables in the local scope at any moment in time. Now we'll explore the differences in what the code looks like between generator expressions and generator functions. So as we said, every generator is an iterator, but a generator doesn't return a single value. Instead, it returns what's known as an iterator object. This may be iterated over one element at a time. So generator expressions look very similar to list comprehension, only they use parentheses instead of the square brackets that list comprehension uses. And they return the generator object. And then we must do something with this object to extract its individual elements. So let's let it come to life by looking at an example. So we first have a list, and the list contains three elements, the numbers 1 through 4. Then we have a variable defined as mult_gen, which equals our generator expression. I times 4 for I in list 1. So we're going to iterate over list 1. And you see now, to be able to extract the individual elements of list 1 and multiply them times 4, as our encode instructs to do, we must make use of that next method. So you see we print next and pass it our generator, mult_gen. So this 4 times. So this is going to extract each one of the elements of the list. And you see we have 4, 8, 12, 16. Another way to do this, and probably a more efficient and concise way to do this, is to use a for loop as we have down here in our example. For x in mult_gen, print x. Same thing, 4, 8, 12, and 16 in our output. So we can think of these as on-the-fly generators, right? Generator expressions, on-the-fly generators. Now we contrast that to generator functions. This is a function that contains one or more yield statements. We can have multiple yield statements as we show here. When this is called, it returns an iterator object, but execution must be invoked by the next or iter function. Unlike regular Python functions, generator functions allow you to resume where the function left off at some later time. So here we have defined a function called oneSimpleGenerator. And all this function does is return 3 words. In fact, it yields 3 words to be more precise. Happy, joyous, and free. So we yield happy, yield joyous, yield free. So then we employ our for loop for x in oneSimpleGenerator. It's going to iterate over the generator object that's returned, print x. So now it will print each one at a time. So happy, joyous, and free. Generator functions can be thought of as reusable or suspended functions. So in this slide, we're going to create some code that takes a word and jumbles it up. We're going to do this first using a generator function, and then we'll contrast that and show you how to do it using a generator expression. Okay, upper left-hand corner, we define a function called jumble. It has one parameter s. For item in range, the length of s, yield, now we'll do some slicing here of the string that we pass in, that we provide as an argument, s item, colon, so take whatever the iteration happens to be, and when it starts off it'll be position 0, colon to the end, right, with nothing on the right side of the colons, to the end, you'll remember from slicing, plus s colon item, so that's 0 to whatever item is. So of course, just to give an example, for the first time this loops around, it'll take the word's 0 position to the end. So item colon will be the entire word that we pass in. By contrast, colon item will be an empty string because it says 0, right? It's implied when nothing's on the left-hand side of the colon, 0 colon to whatever position we're at in our iteration, and the first one will be 0. So 0, 0, by definition, will be empty string. So the caller is res. We immediately turn it into a list when we call jumble because it's an iterator, right? Because it's a yield statement. So we want to turn it into a list so we don't return a generator object, but instead return something that we can see and use. List jumble, we pass it Python, we print res, and you see the code output on the right-hand side. Python, and then it goes through its jumbling until it makes its way all the way through the length of the string that we passed, which is Python. So we iterate over this 6 times. Now we do the same thing, but we use a generator expression. The word we're using here is weekend because it happens to be a weekend where I'm at. Jumble2 equals word, same thing with the slicing, item colon plus word colon item, for item in range, len word. So same thing for the length of the word, and you see the output is very similar when we did this with our generator function. And let's look at the power of this generator expression here, where we feed it 3 separate lists, and we create a list of permutations of all the different types of coffees that could be created amongst all these different lists. Is it hot or cold? What's the flavor? What size is it? So one line of code in essence, one for loop using these lists. For drink in CFS, which will represent our iterator for each of these 3 different for loops that will be in play here against these different lists. For C in C type, which tells us is it hot or cold. For F in flavor, and for S in size, print drink, and bam, we get a bunch of tuples back that tell us these are all the different combinations that you can have. Pretty powerful. And here we'll be using generator functions from the Python standard library. These are functions that take iterables as arguments and return generators. The vast majority of these functions are covered in our Python iterators class as part of this series. The one we'll focus on here is group by. This groups an iterable by a certain criterion. So on the left-hand side, we have our code. We have a long list of tools, all these different hand tools and power tools that you may use. Then we sort tools using the sort method. Tools.sort key length, len, reverse equals true. To use group by, its input should be sorted before we feed it as an iterable to group by. So then we import itertools because group by is in that package. And for lg in itertools.groupby, tools, right now will be our sorted list, comma, len for its length. Then we use some print formatting. Format, we pass L, our iterator L, and then our list of G, and you see what it prints out. It instantly groups all of these different names of tools by its length in reverse order, 12 through the smallest would be 3. So now I'd like to call your attention to some really cool advanced generator stuff. If you don't know who David Beasley is, he is the author of some wonderful books that I have in my collection, the Python Essential Reference, which I have made mention of throughout this course many times, the Python Cookbook, another wonderful book. But he's also like a mad generator, Python generator scientist. So he has on YouTube, Generators, the Final Frontier screencast. It's actually from PyCon 2014. And it is 3 hours of some of the most advanced usages of Python generators and some functionality that is not well known. It's fascinating. If you're so inclined, go ahead and search on that and take a look. He is a wealth of knowledge. All right, Python family, thanks for hanging with me straight to the end. If this has helped you, consider helping me to continue to bring you and others this type of content. Helping is easy. First, I ask that you subscribe to this Yogi Coder page, and then like this video and leave any comments you feel moved to. And third, share this on any and all social media channels so that it can get to your friends and colleagues. Okay, see you next time.